Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. Today, I would like to show you some calculation about acids and bases, especially uh, H plus, which is the same as H3O plus calculations, OH minus calculations, and pH calculations. After you calculate pH, then you can determine the solution is acidic, basic, or neutral. Okay, let's get right into it. First of all, it's good to be able to identify acid and bases and conjugate base and conjugate acid. Here's a good example. When HCl is in water, HCl is obviously an acid. The formula starts with one hydrogen. That's dissociable hydrogens into a H plus. Now that's an acid, therefore water must be a base. Okay, water will take the hydrogen from acid to become H3O plus, and that's the same as H plus. And what's left is Cl minus. That's known as conjugate base. It's related to HCl. Water is a base. H3O plus is a conjugate acid. It's related to water. Okay, now that's the definition of acid and conjugate base, base and conjugate acid. Okay, now this is a good example of acid-base titrations. What is the molarity of barium hydroxide solutions if 37.6 milliliter is required to titrate 43.8 milliliter of 0.107 m HCl? Now, this is the balance equations. Okay, you have one barium hydroxide react with 2 HCl, give us barium chloride plus 2 water. Notice here I convert milliliter to liter by divided by 1,000. As you can see the setup right here, 1 liter over 1,000 milliliters, and that's the volume in liters. Okay, all right, we start out with HCl. This is a stoichiometry using molarity. Okay, you start out with 43.8 milliliter of HCl, which is 0.0438 liters of HCl, and given the concentration, the molarity is 0.107 capital M, meaning mole per liter. Notice we need that to cancel out a liter. We got 0.00469 moles of HCl. Okay, now it's the stoichiometry. That's many mole of HCl. You got 1 moles of barium hydroxide right here from the balance equations over 2 moles of HCl. Okay, notice we need to cancel out moles of HCl because we're looking for moles of barium hydroxide. Go ahead and put in your calculator, and you should get 0.00235 moles of barium hydroxide. If you're off by a little bit, that should be okay. Now, after you get the moles of barium hydroxide, you can calculate molarity. Remember, back in chapter 5, when we learned molarity, is the number of moles divided by the volume in liters. And we already did that. We convert that to liter, 0.0376. When you divide, put in your calculator, you should get 0.0623 mole per liter, which is capital M. Okay, so that's titrations. It's a very good way to find out what's the molarity of a base or an acid that we don't know the molarity, okay, the concentrations. All right, let's move on to OH minus, H plus determination, and pH calculations. Okay, in this exercise, we are asked to calculate pH of a barium hydroxide solutions. Now, in order to calculate pH, we need H+, okay? Now, but we're given barium hydroxide, so that has OH, and two of them. Notice that little number 2 right there? We have to multiply it by 2, okay? Because there's 2 hydroxide in there. So we should take 0.0010 molarity multiplied by 2. We get 0.0020 molarity. That's for OH minus. Okay, now if you know OH minus, you can calculate H plus. They are always together, okay? And this is a fixed numbers. 1 times 10 to the minus 14, that's kW. You always take that numbers, always on the top, always on the numerator, divided by OH minus, okay? And put in your calculator, you should get 5.00 10 to the minus 12. And the units should be M, okay? But when you take the log, you can ignore the units. Take the minus log of H plus, not OH minus, H plus, and that's what we call pH, okay? Minus log of 5.00 10 to the minus 12. Make sure you guys please put parentheses on, or you might not get the right answer. And that will give you 11.3. Because it's greater than 7, pH is greater than 7, this solution is basic. Okay. How about the reverse calculations? If we have pH, can we go back and figure out the H plus and OH minus concentrations? The answer is yes, we can do that. H plus is the same as H3O plus, okay? And it's going to be anti-log. So what you do if you're given pH, and if you want to find H, which is H plus, anti-log mean 10 to the power. And remember, it's always 10 to the minus pH. Anti-log of minus 5, okay? Remember, minus 5, not 5, minus 5, minus pH. Okay, once you have H plus, you can figure out OH minus by 10 to the minus 14. Again, that's a fixed numbers. Whether you put 1 time or not, it's the same. Divided by the one you just filed, okay, 10 to the minus 5. If you put in the calculator correctly, you should get 10 to the minus 9 molarity. Okay, that's how you figure out H plus and OH minus molarity, okay, from a given pH. Remember, always put the minus sign, okay? Always. When you calculate pH, you always put the minus sign too, all right? Well, thank you for watching, guys, and see you all on the next video. Thank you again.